Okay, nice. Cool. Hey everyone, I'm Avi. I work at Google on continuous integration and release. And along with contributors here, we've been working on enabling high frequency releases at Google, something we call probabilistic commits. So for every sort of Google CI presentation, we have to start with this long introduction to how our SDLC works and introduce some terminology that I can't help but use that's specific with Google. So yeah, when you're thinking about CI at Google, you can roughly think about you're doing local development, you're looping with some pre-submit testing and with reviewer feedback. Eventually, you do some submit gating pre-submit testing, and you submit into Google's mono repository, which is this long linear sequence of commits. So unlike some other large software monorepos, we don't have a submit queue. All the CLs, we call commits CLs. All of the CLs get submitted as long as there's no file overlap, and they get a monotonically increasing number assigned to them. So the other critical part of Google's infrastructure that's relevant to understand is that all of Google uses this filter system called Bazel. And in Bazel, you can sort of think about the dependencies between files and packages in the form of a graph. And when you look at this graph, you have these library and binary build targets, and you have test targets that you can execute. For us, comprehensive testing corresponds to getting all of the transitive dependencies or transitive downstream uses of files that are changed in a CL. And this is important because of how Google, using this monorepo resolves all dependencies at the same version, you can potentially be broken by other people, by a library that you depend on. It can cause your project to break, even if, because you're not able to pin versions. So, okay, so zooming out, you can largely think of our entire CI and release system as corresponding to these sort of pre-submit steps, pre-submit testing, submission. We do some testing at pre-submit time that's scoped to tests near the files that are being changed. And for post-submit testing, we do this comprehensive testing that I'm talking about at some interval. So, an hour and a half, we're running all of the tests that could have had their status changed. And this then forks into, well, if we run these tests and we encounter a failure, we need to have some mitigation strategy. We call this the unhappy path, where we need to find which commit broke these build or test targets, and then roll back or notify the developer. In the other case, we go on to release. So in the past, we've done a lot of work on this unhappy path that we've published. For detecting breakages faster, we have these ideas of speculative cycles. So, as I said, we sort of comprehensively test all targets that could have broken every hour to an hour and a half. But we also, every 20 minutes or so, run targets with a predictive test selection using an ML model. We have this flake-aware culprit finding algorithm for finding the commit that caused this regression. And then we have an auto rollback system that tries to, with high confidence, roll back a commit if it caused breakage. So this is what we've talked about in the past, but for the first time, we're going to be talking about the other side of CI and release, the release aspect. And so to talk about this, we sort of have to break down how CI and release is configured at Google. So broadly, what you should take away from this is, we have these set of build and test targets in the monorepo. And we have CI projects. So we have a unit testing CI system TAP, which is what many of us in the room work on. There's an integration testing CI system called Guitar. Each of them, there's a many to one mapping of, or many to few mapping of targets to CI projects. And then multiple CI projects can be included in a release project to gate releases on having passing statuses from all of those CI systems. So when we talk about the release process, what you have is roughly this. Unit testing is fast, and unit testing every, like I said, every hour to an hour and a half, we're getting a green signal. This green signal can trigger integration tests, and both of them together for your release project produce what's called a golden commit, where you're saying it's okay to release, to build a new release. And so this starts, then you have sort of release configuration, and your release configuration controls at what frequency you're going to use these goldens to create candidates to push, and then to push to different release environments. So minimally a staging and a production environment. So, okay, finally we get to, what does this talk about? What is the problem? Well, the problem is that, given this decoupling, given these automated release schedules, and also the latency and sparsity of our CI signals, when you have breakages or a lot of breakages that affect certain release projects, you can harm their release velocity. And for some of these projects, they care about getting daily releases, and if they're broken enough, the back and forth for breakage resolution might cause them to miss their release. So to sort of break down this problem, I have this very text-heavy slide, so hopefully we can sort of talk through this. So the scenario is roughly that you had a successful release at this CL7 in the history, and you have a new breakage that's introduced that affects your project at CL13. This breakage is resolved later at CL31, and this is all just to say, for a breakage, you have a detection latency, how long it took you to find that something was broken in the first place. You have some sort of mitigation latency for how long it took you to actually, get to a commit state where you could release. And then you finally have a latency that's introduced by your CI signals and release cadence, which is this release latency. And so this is a simple case, but what if we modify it slightly? What if we say, hey, you're a project that gets broken a lot, and immediately after you fix your previous breakage, you're broken again. In this scenario, if your CI signals are not frequent enough, you can end up in a situation where you essentially won't get any releases through because you're never quite aligned at a commit that is green. And so this is why it's important to have more frequent CI signals for release. And so some of our other work has looked into CI signals improving CI signals for people fixing their tests, but this is CI signals for the release infrastructure, which matters just as much. I think we can talk about this later, but it's very interesting that different organizations have different desires on how frequent they need to release. So it might surprise you to know that this is a problem, and maybe some teams want multi-day releases. So anyway, our solution is probabilistic greens. The idea is, simply we have instead of needing goldens to be cut on a full signal from our CI systems, we do a prediction. We give you a high confidence or low confidence that your project is going to be green. And we do this by aligning it with our probabilistic test selection. So, every 20 minutes, we're going to predict, at a new commit, is your project green? We're using some simple inputs, but the idea is that our test selection, algorithm and targets were run at the commit that we're doing this project prediction at. So when we do our speculative testing, if there's any failures, we're going to short circuit, and obviously we can't have a release. In the case where we don't observe a failure, then we will do this prediction. And the reason I'm not going to talk much about this model is the model itself is not very important. The idea is that we are able to cut releases opportunistically. And so our test selection, the better our test selection is, the more likely we'll catch breakages anyway, and not need to rely on it for, not need to rely on comprehensive testing to unblock release. So, and you might say, okay, well, if we're gonna cut releases off of a probabilistic signal, what's the failure case? Well, here there's no failure case because we just push the comprehensive testing later. We perform the comprehensive testing before prod promotion, the promotion to the prod environment. You can kind of think about it like branch prediction in terms of, hey, in one case, I get time savings. In the other case, I get some noise, but I don't, I'm not losing safety here. So that's important. So going back to our previous examples, you can, just to show that you would get, potentially a latency reduction for release. And critically, when you're broken, often you have the chance of getting your releases cut between breakages, in the spans between breakage durations. And we've observed this in practice. So, okay, now for the biggest part, measurement. For telling how we do, how well, what is the impact of this whole process? We have to answer the question, what do we care about? And what we actually care about is very tricky. It's the end user's perception of velocity, of how fast they're going. Critically, they might not even care. There's many commits that they commit that they might not care how fast they get into production. There's other ones that they care a lot about. So this underlying sentiment is hard to measure, except if they complain, right? But the first step that you have to take is do some sort of deterministic measurement. And the most reasonable thing to use is time for relevant CLs to reach your release environments. And so how do you measure relevance? Well, you could say, hey, any code change that, is part of my release binary, that is a relevant change. And, this is very there's a lot of transitive dependencies. This can be very inclusive. And usually the release owner doesn't care about many of these dependency changes. You could say, well, your release project, it has certain, directories configured for, these are, directories that we care about. And oftentimes those can be, too selective. Maybe there's some shared directories between your team and other teams that matter. So it's very difficult. And I think the future North Star is that we will have some sort of AI-driven relevancy or risk signal because of the need for this to be dynamic. And this is just a conjecture. We'll see where this goes, but for now, what we can do is we can be conservative. So we can say, hey, any CL could be relevant. And so in this case, what you really care about is, what is the time from the previous successful release? So the submission time of the previous of the commit at which the previous release was cut to the time of the current release. And this basically captures the latency or for any CL in between that newly gets into a release. So we call this submit to prod, but in this case, since we are interested in unblocking the candidate creation, we care about submit staging. So, but there's another problem, which is release configuration is decoupled from CI. So you as the release owner can configure the cadence at which releases are your candidate creation or your pushes to staging. So even if we speed up the CI signal, you might not actually get faster releases, right? Unless you actually configure your release project accordingly. And so you can think of it like this. We might produce more goldens. So in this example here, we produced 2 goldens after the previous successful release, but they didn't matter because the cadence, was it only tried to make a new release at CL33. And so you can split this up between the portion that of the latency that CI contributes to and the portion that release contributes to by looking at the time to the first golden. So, okay, so we are still in the process of launching this system. So we picked one of our, sort of star projects in our pilot program for these numbers. And so what we roughly find is something like 27% decrease in our total submit staging latency. But what we find is a 63% reduction in the CI drag. So this is by quantifying the difference. You can give suggestions on how to change release configuration, essentially. Okay, well, I just want to end this by going back to the idea of what do we actually care about? Now we've drilled down into how long does it take you to reach staging? And this is pretty far from what the developer actually cares about. But oftentimes, I think these proxies are good enough, and they're actually the most important part of the project. So this is, you see this title slide and it says, probabilistic greens or predictive, like we use an ML model. But I think the measurement's the most important part because it makes it possible for other projects that we have, potentially on the release side to decrease total end-to-end. So, okay, so what are next steps? Well, there's 2 ways to go here. Like I said, we've done a lot of previous work in what we call the unhappy path. When you have a breakage, how do you resolve it faster? So I'm doing some work here on trying to improve our predictive test selection by being more by processing individual commits in a more high fidelity way, using LLMs and using knowledge mined from previous breakages. I think this will likely be where we head to do fine-grained test selection. And similarly for mitigation, flakiness is a persistent problem. Even being aware of flakiness and established flake rates may not be enough, and that harms your sort of auto rollback frequency. So these are things that we're hoping to tackle on the CI side. And now on the other side, one thing I sort of want to emphasize here is what you realize is that this is a very heterogeneous ecosystem. So there's many different types of projects that have many different constraints on how often they want to release or what they care about. And so far, we've had a one-size-fits-all solution for these projects. And the other thing that we noticed, right, is that CI and release being decoupled can cause problems for trying to really decrease what the total end-to-end latency that the user cares about. So there's steps towards what's called project rate scheduling, where you're doing vertical integration across CI and release, but for specific projects instead of CI for everyone and then release for everyone separately. So that's about it. Yeah, I'm open for questions. And first, I wanted to say, we had a lot of contributors. Most of them couldn't make it, but they all helped build the system. So.
So I see some similarities between something you were talking about and something that Morgan was talking about, which is shifting all of the tests later in the cycle, right?
Mm-hmm.
And I'm wondering, how does AI change that equation? Because I'm worried about AI generating slop and that gets caught much later on. So like, are we going to have a higher rate of rollbacks
Right.
now that we shifted all the testing right instead of shifting it left?
I think it puts a lot more pressure on, for example, our test selection. This has been happening for a long time, where even purely from resource constraints, we're going to have more pressure on predictive test selection to catch breakages early. But now I think there's really an emphasis for, also a risk signal per commit, right? How do you, and you can use that risk signal to then gate, how much can we rely on these other systems to just let things through? So I think that's going to be the answer. And, the opposite side of the AI slop is that LLMs also help this, to be able to do this in the first place, because before, many of our approaches to be intelligent couldn't really look at the content, the semantic content of commits. So, we'll see how it actually plays out. But yeah.
You also talk, you mentioned that you were able to reduce CI drag.
Yeah.
Quite a significant margin with, I guess, do you have some examples that you could share?
Yeah, so I just meant that this sort of predictive project status was enough to cause that reduction, because like I said, so before you were getting your CI signal at 1.5 hour increments, 1 or 1.5 hour increments. And so if you were a project that's broken often, that's gonna cause all these delays. The project that I showed is one that is broken often. And so purely with our system, we have some examples where we hit this scenario that I explained, where you have multiple breakage periods and you're able to get a release in the middle because you're giving this opportunistic signal more frequently.
No changes in configuration or nothing, just that's fantastic.
Yeah, well, actually for this project, we coordinated with them to change their release frequency. But that's part of the value of the measurement. Is with the measurement we can point, if someone says we have a slow release and we want it to be faster, but say, hey, you should, we've now decreased the CI impact on your release latency. Why don't you change your configuration? So yeah, but
Thanks for your talk. One thing that I didn't get is whether with this system you're changing the criteria for pushing to staging environment or not.
Yes, we are. Yeah. So this looks like, create candidate and staging is, two separate elements here, but you can kind of think about it as create candidate is pushing to some starter environment. I simplified this diagram. We have another release environment for staging. But yeah, it gets pushed to a release environment.
Okay, so potentially broken feature can push to staging.
Yes. So like the only point at which we know for sure nothing is broken is after this prod promotion. So this is the sort of trade-off, right? The trade-off is between how frequently you're getting the releases and what we call late stage testing failure. So the amount of time this box here for prod promotion testing results in a failure being found. Yeah, I didn't report the numbers because we didn't find that it's increased significantly so far, and we're still ramping up. So, but that's the conceit.
Okay, and then the trade-off is ultimately selected by the team who manages the staging environment, right? So if they want to faster pushes to staging,
exactly,
they would need to accept a higher risk.
Yeah, and actually there are some teams that prefer this scenario, right? Like even if tests are broken, they might get some value from seeing whatever new commits they have in some environment, and they might be willing to, they might actually prioritize that over having a clean or green staging. So there are cases.
Yeah, the whole purpose of staging environment is to identify problems. So
right.
It's not like, okay.
would have a quick question. Thank you for the great talk. The staging environment, that's gonna be shared between different services, right? So it's kind of an integration test, right?
Yeah.
Yeah. So you potentially have the issue, like stuff gets broken and people do not get the staging not even because they broke something in their system, but someone else broke it in their system and like the core library, and then I don't get my staging because
Right.
they did not have to do that comprehensive testing upfront, right?
Right.
Is
Right.
that something you have experienced?
Yeah, I mean, we haven't done our full 100% rollout, so far we haven't seen this problem, but maybe it's specifically for our pilot projects. But you're right that this is a concern, and I think the ultimate state that we might want to end up at is that every promotion has some testing, right? It might be this sort of continuous approach where here you see just staging in prod, but actually we sometimes have multiple. We have like auto push staging in prod. And so you could think of a scheme where you're continuously adding more tests between each stage. And usually for us, those sort of inter-team sort of service dependencies in the release environments, they might exist for your QA environment, but not for your earlier staging environment. So yeah, it gets complicated, but you're right. That is a concern, and it's something that we are not quantifying.
One thing I did want to mention, I don't know if you mentioned it in the talk with like Goldens. So to your answer more your question, you can have multiple projects that are similarly related within that golden thing. And if they're green, then you have a lower chance that like something else broke that you care about also.
Okay.
Right. You could include you often do include CI projects that might overlap with other releases that you're sharing your.
Yeah. Okay.
But yes.
So in this case, we have any possible how to roll back to the staging environment? Like let's say you see something wrong with the staging environment, and we automatically roll it back.
That is, I think, up to the release owner.
Okay.
Yeah.
I will say. Yeah, so if you view those stages as like a different form of verification than traditional testing, because they have like metrics associated with them in terms of like RPC performance or other things like that, task crashes, etc. If you see a failure, it does get automatically built back of that sort. But if you get a test failure during the prod promotion testing, we don't yet have automatic fixing ready, but that's something that we're interested in having. If you looked at the paper we presented in industry track, the taming the variance paper, it's actually quite rare to have the failure in prod promotion. And like this project, which sort of like took it to the next level, like we're still seeing extremely rare failures. Let me see what the failure rate was for that. On the taming paper, we're talking about like a failure difference. It's like 0.01% or something like that. And so they're quite rare. So it's like the impact of doing the auto fixing there. It's like better to do it on the earlier stage of the pipelines where the failures happen much more frequently, but it is higher cost for the failures do happen. I don't know, did you have the number for?
Yeah, so I mean,
increase the late stage failures?
so far the late stage testing failure rate has stayed the same.
Yeah, so we have not seeing any differences. So like the model's successful.
Yeah, so the problem is like the definition of failure in staging, like different from the failure in prod.
No, I'm talking about right now the promotion to prod promotion testing failure.
Okay.
But like we're also not seeing a difference in canary failure or other things that would prevent staging promotion. Like we are like there has not been any like from our metrics any like issues with doing this. There hasn't been any like escalation of like, oh, you didn't run a test and it would have caused a bug and prevented this from going through staging. We haven't had an escalation about that. That's been running for months now.
Yeah, and qualitatively, this specific case that I showed, we had someone reach out and say, thank you, you know, you got us a release between our day of breakages that we often have, so.
Yeah, so anyway, yeah, effectively, it seems very safe because you won't go to actual fraud. And it seems just like to be a productivity win at this point to us to delay the testing and do less.
Then that's we bring up the opportunity for you to actually clean up the test. Because that's not you skip, might be not important.
Well, yeah, I don't know that we're quite to the point of like test suite management, although that's something that I'm interested in. But one thing that I think maybe is in the background for the BMW talk, the Okta talk, the Meta talk, and our talk is that when you have flakes, like your tests in your test suite and you run them all the time, actually running tests, just running tests brings up the possibility of the test failing for no reason from a flake. And so if you just don't run the test, you actually are saving even more time. So like if you can predict that the test will pass and you don't run it at all, you don't have to pay the cost of rerunning the test, never mind running it the first time.
So what I'm saying is like you are not running the test, but you just delay the some later. Like for example, as a release, right? Then you can run it. And they can run the now. But it's later the cycle.
Yeah, but like so the create candidate, it runs every 2 hours.
Yeah.
So if you run every 2 hours and you have a 10% failure rate, right? So that means you're probably gonna have like at least you're gonna have like 1.2 expected flakes per day, which will require reruns to fix. So if you move that to running once per day, so you only run that particular test before fraud promotion because you're predicting it will pass.
Yep.
Now, instead of 1.2 failures per day, you have, and you're running it once per day, now you have 1 failure expected every 10 days. So you have like reduced the cost of dealing with that particular flaky test by just running it less frequently.
All right. Thank you guys very much for the great discussion. Thank you, Avi, for the talk.